When compared with human learning, machine learning is an extreme extension of the old not being able to see the forest for the trees metaphor, because computers essentially reason by building a map of the forest, tree by tree, then storing in information so that they can get through the forest later. When an AI learns to play a game like Atari's Breakout, they play the game again and again and again until they can narrow down their movements pixel by pixel to a point where it looks like actual gameplay. After hundreds of hours, computers begin to identify the most optimal way of playing a video game, which they then replicate flawlessly ever after. This is very different from humans. Even highly skilled human players must remain vigilant not to make a mistake, and they rarely can replicate gameplay every single time. Historically, deep learning programs have required continuous hand programming to help them along. Now, hand programming is not analogous to the kind of help human students receive from their teachers. When programmers have to hand program a deep learning algorithm, it means that they are going directly into the code of the program and changing the way it processes and even perceives the information. So while these programs can learn from their past experience, this learning is limited in scope, and they cannot seem to be taught or learn in a traditional human sense. They require humans to watch their development, as they lack the metacognitive ability to self-monitor. And they will repeat unproductive responses over and over again and never detect the problem. In other words, if a computer algorithm is to detect a certain class of errors, it must be programmed to do so. A humorous example of this occurred when Eric Brown, a developer of IBM's Watson computer, to prepare it for its television performance on Jeopardy, he sort of let it learn natural human language on the internet. Ultimately, he had to go back and hand program the algorithm because the process resulted in Watson peppering its responses with slang taken from the Urban Dictionary. So while computational neural networks are based on a theory that is analogous to present theories of neuronal function, they do not appear to actually be functioning in an analogous way. It is also telling to point out that despite the complexity and power of the present generation of computation, it appears to be impossible to program anything like the human capacity for understanding. Despite the tremendous advances in the field of machine learning, it is presently unclear if what is being demonstrated is a precursor that will emerge into full-blown conscious metacognition in machines, or it'll kind of remain a proto-metacognition and never achieve anything akin to a human, but still be a very valuable tool for us. Or perhaps, if computers are able to liberate themselves from their programmed parameters without needing direct human intervention, maybe we'll find that their capacity for self-reference and understanding is something very different from the cognition that we were all expecting. The part I find exciting about following this whole line of research is that the discovery that settles all of these questions could be made tomorrow, or they may not be made at all. We just have to wait, find out.